Hello. Today we will learn how disks and file systems work in Ubuntu, and also how to install and remove programs with APT. You will learn how to understand where disk space goes, why diff and do show different numbers, and how Linux works with packages and updates. This is one of the most practical topics for everyday work in Linux. When people say I have a disk, in Linux this usually means a few different things. There is a physical disk, for example an SSD or HDD. On the disk you can create partitions, and on these partitions you create file systems. So these are three different levels. To make it very simple, you can imagine it like this. A disk is like a house. A partition is like a room inside the house. And the file system is the set of rules for how things are stored inside that room. The file system decides how Linux stores files, folders, permissions, metadata, and internal data structure. If we talk about file systems in Ubuntu, the one you will see most often is EXT4. It is one of the most common file systems in Linux. It is reliable, easy to understand, and good for normal everyday work, so it is very often used by default. If you installed Ubuntu and didn't change anything special, you probably have EXT4. There is also XFS. This is also a mature and widely used file system. It is especially common on servers, where stability and work with large amounts of data are important. You can see it not only in Ubuntu, but also in many systems from the Red Hat family. For a beginner, the most important thing here is not the small internal differences, but the main idea. A partition by itself doesn't mean you can already store files on it. For Linux to work with data normally, a file system must be created on that partition, for example EXT4 or XFS. So the chain looks like this. There is a physical disk, partitions are created on it, a file system is created on a partition, and only after that Linux can mount it and work with files and directories. So, in a very simple way, a file system is a set of rules that Linux used to store data and a partition. Now, let's see how to view this in practice. The lsblk command shows block devices, disks, partitions, and sometimes mount points. For example, SDA, this is a disk, and SDA1 and SDA2, these are partitions on the disks. The important thing here is not to remember the names, but to understand the idea. There is a device, and inside it there can be partitions. Now, let's check how much space is used on the file systems. For this, we use the command df-h. df-h. df shows file system usage. The -h option makes the output easier to read. Sizes are shown in megabytes and gigabytes. Usually you can see the full memory, used, free, and the mount point. The main idea is this: def shows information for the whole file system, so it answers the question how much space is used on the partition as a whole. Let's look at another command. du-sr tilde. Du means disk usage. This command calculated at the size of files and folders by going through the directory tree. For example, this command will show the size of your home directory. And if you want to understand which folders inside it takes space, it is much more useful to do this. du -h -max -def 1 tilde. This is a very practical command. It shows the size of first level directories inside your home folder. For example, you can quickly see how much space specific folders take. When Linux runs out of space, this is one of the most useful commands for the first check. And here comes a very common question. Why can df-h and du-sh show different values? Because they answer different questions. The f shows how much space is used on the whole file system, but the u calculates the size of specific files and folders that it can see inside the directory you gave it. The difference can be happen for a few reasons. First, the u checks only the part of the directory tree that you told it to check. Second, there is file system service data. Third, there can be deleted files that are still open by running process. And fourth, there may be directories that you cannot access. So, df is a top view from the file system side. The u is a bottom view from the file and directory side. That is why these commands do not have to show the same numbers. Let's look at a very important practical case. Sometimes you delete a large file, for example a log file, but the free space does not increase. At first, this looks strange, but in Linux, the file is not just a name in directory. If some process still has this file open, the data still exists, even if the file name is already removed. So, the file seems to disappear from the directory, but the process is still working with its file descriptor, and disk space is not freed yet. This is very common on servers, especially with log files. Let me show you the idea with an example. First, in the terminal, create a large file and open it with tail. Okay, 8 minus L 100 megabyte big file log. We create our file. Need to open them. Tail minus f big. Okay, let's open another terminal, and here check the space. Def minus h used 6.1 gigabytes. Let's delete this file. Rm big and check space again. You see, nothing changed. Because file still used. Tail process still keeps the file open. Now we can close. Ctrl C. Tail stopped. And check space again. You see? Now space is free. This is very useful to understand. Deleting a file doesn't always mean to space is freed immediately. Let's move to mount points. In Windows, many people are used to disk letters like C, D, and so on. In Linux, things work in a different way. Here, a file system does not get its own separate letter. Instead, it is mounted into a certain point inside one common directory tree. For example, a USB drive may be mounted in /media/username. An extra disk may be mounted in /mnt/data. So the file system becomes part of the common Linux directory tree. This is the idea of mount. You can view current mounts like this. Find mnt. The umount command doesn't the opposite. It unmounts the file system. The main thing to understand here is the principle. In Linux, everything is connected not as a separate disk with a letter, but as a part of one directory tree. Let's look at the fstab file. etc fstab. This is a config file that tells the system what should be mounted automatically when the system starts. For example, if you have a separate partition for data, you can write in this file, and after reboot, the system will mount it by itself. We will not go deep into the syntax now, but you should know the main idea. Fstab file is a table of permanent mounts. Usually it includes the device, the mount point, the file system type, mount options. For a beginner, it is enough for now to understand what this file is used for. One more important concept, inode. When people say the disk is full, they usually think only about gigabytes. But in Linux, you can run out not only of data space, but also of file count. Every file uses an inode, a special structure that stores its metadata, permissions, owner, size, timestamps, links to data blocks. If you have a very large number of small files, you can get into a situation where there is still free space in gigabytes, but all inodes are already used. You can check this with df-i. df-i. Oh, I have a lot. Use only 1%. No, 11, okay. If the system cannot create new files, but it looks like there is still free space, you should check not only df-h, but also df-i. A short part about swap. Swap is an area on disk that the system can use as extra memory if RAM is not enough. It is very important to understand this correctly. Swap is not a replacement for RAM, but more like a backup mechanism. It can help to survive low memory, lower the risk of processes crashing, and sometimes it is also used for hibernation. You can view swipe like this. You see, I don't have swap on this virtual machine. In Ubuntu, swap can be made as a separate partition or as a separate swap file. Let's move to the second big part of the lesson, installing programs. In Ubuntu, the main package manager is apt. The most important basic commands are apt update, apt upgrade, apt install, apt remove, apt purge. Let's go through them one by one. apt update. Let's start with this command. Sudo apt update password. Working. This is a very important point. Update doesn't install updates. This command only refreshes the list of packages available in the repositories. So the system gets fresh information about which program versions can be installed now. Beginners very often think that update already updated everything, but that is not true. It only updated the information. The next command actually installs the available updates. Sudo apt upgrade password. Yes. So the command pair looks like this. First, sudo apt update, then sudo apt upgrade. The first command refreshes the information. The second one installs the updates. Take a pause. Oh, yeah, hold on. And now let's install something useful. For example, htop. Install htop. All done. Htop is a useful program for viewing processes and system load. This is a good example because it is a real useful tool, not just some abstract package. After installation, you can start it right away. Htop. Yeah, very nice. And you will see that the package is really installed and working. If you no longer need a program, you can remove it. For example, sudo apt remove htop. Sudo apt remove htop. Sudo apt close remove. Yes. Yeah, it's very quick. All done. The remove command deletes the package itself, but some config files may stay in the system. If you want a more complete removal, use sudo apt purge htop. Sudo apt purge. Yep. No, nothing extra, but anything. So, remove normal removal. Purge more complete removal. Let's see how to search for packages and get information about them. For searching, you can use apt search htop. Apt search htop. Yeah. Different programs. It's our. And to view detailed information about a package, apt show stop. Apt show stop. Yeah, all information. Here you can see description, version, dependencies, size, package source. This is useful when you are not yet sure if this is the package you need. Now let's briefly look at the difference between apt and apt-get. For normal work by hand in the terminal, apt is usually easier for beginners. It has a clearer interface and more user-friendly output. apt-get is an older tool that you often see in old guides, in shell scripts, in automation, in Docker files. So in practice, you can remember it like this. For everyday manual work, usually apt. In old scripts and automation, often apt-get. Besides apt, Ubuntu also has other ways to install programs. For example, snap. Snap is a package format from Canonical. In Ubuntu, it is often already built in. For example, you can view installed snap packages like this. Snap list. Yeah. Another way is Flatpak. Flatpak is a similar idea also across distro formats. It is often used on desktop Linux to install applications in a more isolated way. If Flatpak is installed, you can view the package list like this. Flatpak list. Flatpak list. I don't have Flatpak. And third way is PPA. PPA is an extra package source for Ubuntu. It is usually used when the program is not available in the standard repositories or a newer version is needed. But here it is important to be careful. The more third-party PPAs you add, the higher the risk of conflicts and instability. So the basic rule is this. First, check the official repositories, and only after that think about PPA. It is useful to understand the bigger Linux picture, because different distributions use different package managers. For example, Ubuntu Debian apt, Fedora, Rocky, Alma Linux, DNF, Arch, Pacman, OpenSUSE, Zypper, Alpine, APK. You don't need to memorize all of this right now, but it is useful to understand one thing. In Linux, installing programs solves the same general task, but different distros use different tools. One more very useful command. dpkg -l and command stop. It shows which files were installed by the package. This is very useful if you want to understand where the executable file is located, which main pages were added, which paths were changed by the package. This is a real practical command that is good to know. So, today we learned how Linux works with disk, partitions, file systems, and mount points. We also learned how to check used space and understand why it doesn't always behave the way we expect. In the second part of the lesson, we got familiar with apt and learned how to search, install, update, and remove packages in Ubuntu. In the next lesson, we will move to another very important topic: users, groups, and permissions in Linux.